So thank you for the invitation. Actually, we received the invitation like 2 weeks ago, and the person who should come is not available. So they asked me, and I was in the middle of the desert in Saudi, selling their almond and olives to prepare the presentation, and it was like a headache for me because the presentation is like 2 hours and like 500 slides. So this is like cutting part of your body. Which part you choose? So we decided to eliminate all the part of Agromilora and concentrate only about the super high density system, which I want to keep very clear here that I mean, in Agromilora doesn't have anything against the model of California. The only thing is we try to develop different model, which maybe, as Bruce said, it's maybe more adapted to the Spanish or European conditions than the weather condition in California. But it doesn't mean that we have anything against the model in California. So let me give you very fast, well, the presentation I made, as I said, I did it in the desert without internet, and once I had chance to send it, I sent it, and actually when I saw it during the weekend, I wanted to make some changes, but it was already so late, so we will stick to the one I sent already like 10 days ago. So even the date is wrong. Well, Agromilora is a nursery. We started to work in Catalonia, north-west of Spain, in 1986 with 2 main objectives. Just to give you an idea about the meaning of the name, Agromilora mean in Catalan, agro mean agriculture, and millora mean development or improvement. So from the day one, the idea of the company is not only to make plants, which logically as a nursery, this is our main objective, but also to develop new models of agriculture. As I said, the meaning of the name Agromilora means agriculture improvement. So as I said, we had 2 objectives. Number 1 is to produce plants. We started in Catalonia, and after that we found Catalonia very small for us, so we jumped to Spain, and after that we found the rest of Spain is small for us, so we jumped to the rest of the world. As I said, a nursery, our main objective is to make the best quality plants, but also we thought that if we find a model which help the growers or the farmers to make money, will help us to sell more plants. I mean, if they make money, we will make money with them, because it is, I mean, we connected to each other. So we started to develop different models of agriculture, and one of the major success we did was the super high density system in olives. Just to give you an idea, olives didn't change for 2,000 years. I mean, since Arabs and Phoenicians sent olives to the Iberia Peninsula, they used to plant it in the same way for 2,000 years. Last 25 years, since Agromilora, since 1994, when Agromilora started to develop the super high density system, I mean, it was like a revolution in the olives. So we thought, well, if it works with olive, why don't we try with other crops? And as I said, well, let me go fast in the talking about Agromilora. We have, at this moment, we have 12 subsidiaries. 3 in the States, California, Oregon, and Florida. 2 in South America, Chile and Brazil. Next year, 2020, we will open in Peru. We have in North of Africa, Morocco and Tunisia. We have in Middle East, Jordan. I'm the general manager of this subsidiary. We have in Turkey, which is also for the Central Asia and Turkey countries. We have in Australia, and we have plans to open new subsidiaries when we have the staff to do it. All our plants are made by, except olives, made from in vitro. We have different in vitro labs, except in Jordan and California. All the rest of the subsidiaries have in vitro lab. And what we do in the lab is the root stocks. what we do, what we are looking for when we talk about the rootstocks, we are talking about high productivity, less vigor, I mean, in this case, adapted for the super high density system, better soil adaptation, and tolerance for diseases. Just to understand, this is the last slide talking about Agromilora. Yeah, so Agromilora is like a platform between the breeders and the growers. Just to give you an idea, we are like a printer. We don't write books. We don't read books. We just print them. A grower come and say, I need this rootstock with this variety. We do it for him. So one of the main objectives is to make plants. At the end of the day, this is a nursery. But also, one of the other objectives is to develop the system, the agriculture models. At the end of the day, as I said, it will help us to sell more plants. So what we found, what's the challenge which nowadays the growers are facing? Well, we mentioned 4, but there is a lot. I mean, we can mention 20, but we mentioned 4 because we found them one of the most important problems. Number 1 is the labor. Labor is not a problem of only cost. It's a problem also of availability. I mean, nowadays, it's not only what it costs you to have a worker. It's also issue of to find this worker. And if you have low cost, I mean, if the labor is cheap, and if you have them, how to manage them in the field. This is again another headache. Number 2 is the prices and the payback period. Let us put it that way. We now, Olem is a big company. They control a lot of production and things like that. But small growers or farmers and big company doesn't control the price. Price controlled by the market. I mean, let us keep this clear. No grower in the world never mind how big, what is the size of the grower, can say today I will sell my product with this price. This is not existing. But a grower can reduce his cost. And this is the only thing which a grower can do. So this is very important. The price is the market. The cost belongs to the grower. Also the payback period. The payback period is a big issue. I mean, for example, today we listened to a beautiful presentation about pistachios. Pistachios start to get in production after 12 years. It's a lot of years for a grower, for a farmer. So we try to find some way to reduce the payback period. Then the technology, this is something not all the growers have access to the technology, and also the right rootstocks and the varieties. So we decided, I mean in Agromilora, we decided, as I said, to look for the super high density system. The super high density system give you high efficiency, early getting a production, after 3 years you start to harvest, less labor, this is very important, use of machine, I mean to reduce also the labor as much as we can, and improve the fruit quality. In this case, almond is not a very important, the fruit quality in almond is not very important, but we are talking also about super high density in citrus, we're talking about super high density in stone fruit, so this is very important. As I said, we started with olives. This is a very beautiful orchard of olive. Olive didn't change, I said, for 2,000 years. Nowadays, we have more than 400,000 hectares of olives in super high density. Some countries, without the super high density, I mean, it's not possible to plant olives, like the States. I don't know, South Africa, Australia, where the labor is very expensive, it's not possible. And nowadays, there is a lot of production of olives in those countries. Almond, as I said, if olives, the super high density system works in olive, why don't we try it in almond? If we have the right rootstocks and if we have the right varieties. Citrus, well, this is for the juice, I mean for industry. But also, if you want to harvest by hand, it's much faster than harvest a big tree. Stone fruits, in this case I think it's apple, but anyway, stone fruits. Stone fruits also for industry, but also you can harvest by hand. And harvesting by hand is much faster in the super high density when we talk about wall instead of big trees. Well, this is some prices of the labor. We put France 12 euros per hour, Italy 10.5, Spain 7.5. Spain still very cheap, even although it is very cheap, but people trying to get rid of labor is not available, and if it's available, it's difficult to manage. And then different countries we put here. For example, we put the States between 15 and 17 per hour, which is also quite expensive. Well, I will jump this slide. This is for stone fruits. So this is a beautiful slide which shows you the situation in the main three countries in almond: Spain, the States, and Australia. The most important data in this slide is that Spain was 665,000 hectares, 665,000 hectares, produced less than Australia was 47 hectares. I'm not talking about the States because this is different league, but I'm talking about comparison between Spain and Australia. With 15 times less, Australia can produce more than Spain. The only data here that in 2017, between 2017 and 2018, Spain was able to increase the production 10%. But why this happened? This happened because of this picture. As you can see, this is beautiful picture of the orchard in California, and this is our orchard in Spain. Spain, almond is a marginal tree, grow and dry. And growers say, well, if I get 100 kilos, it's more than enough. Anyway, I'm not going to spend any money there. So they don't deal with the trees as a fruit tree. While in the American and Australian model is totally different. I mean, look to the picture. But also, the American model is very expensive in terms of natural resources. I mean, this is like a fancy house. This is like a fancy house. I mean, to maintain this production, you need, maybe we're going to leave it for our colleagues from the States, but you need a lot of water, fertilizers, and also the impact of the environmental impact. I mean, how they collect the fruit from soil, sanitary issue. I went to the States 2 times, one of them during the harvesting time, and the dust is something incredible. That's how they do it. I will keep it for our American colleagues to give more idea, but this is the American model. Meanwhile, this is our model. What we decided to call it from 3D to 2D system. By the way, if I exceed about the time, please, Katrina, control the time because this is a long presentation. How? Okay. So we decided to call it from 3D to 2D system. What we mean with 3D? 3D is a big tree, 3 dimension. Nowadays we are talking about 2 dimension, 3 dimension, things like that. And we decided to go for 2 dimension, which is a wall, thin wall, which is much easier to manage. I'll put this also fast. This is the difference between a big tree and a small tree. What's the difference? The difference is this shady area in the middle of the tree, which is between 25 to 35%. Let us put it an average of 30%. Less of the rest of the tree is producing, which is 70%. But those 30% you have and doesn't produce, you need to maintain by water, fertilizers. Meanwhile, when you go to the 2D, the production area is, or the producing area is like 98%. This is a scientific paper, and the reason mainly is about the light and reducing the permanent wood. This is the main secret. There's no other different secret. And also, when it comes to the stone fruits, you also concentrate all the, also almond, you concentrate all the production around the main axe of the tree, which make it much easier to harvest by machine. This is another nice slide. This was made in 1978. I mean, this is very old experiment, and it shows you the difference between wood, leaves, and fruit. In big trees, you have 41% of wood, 14% of leaves, and 45% of fruits. Meanwhile, when it comes to small trees, you have only 14% of wood, which doesn't produce, just maintain the tree, 9% of leaves, and 77% of fruits. Having in mind that talking about olives, talking about almond, or talking about any type of trees, wood and fruit compete in the same area. I mean, tree goes for wood or goes for fruit, because, I mean, it can make both. Another nice slide to understand a little bit the difference between 3D and 2D. As you can see, this picture in the bottom of the slide. This is what you call it, Catalan vase tree. So it have a lot of branches. So in the super high density system, we just take the same branches and put it in one line, as you can see in the next picture. I mean, just organizing the tree and trying to maintain the maximum percentage of light, which for sure will improve the quality, but also will improve the production. This is, for example, this picture is coming from Australia. As you can see, this also show you this is a beautiful tree. I mean, we don't have doubt about that. And for sure, the American model is a successful model. I mean, this is very clear. They produce 85% of the world production. But look to the tree. Look the area which is not producing or with permanent wood. This part need water. This part need fertilizer, and this part will not produce anything. All the production is coming where the light can penetrate. So we are talking now about resources, not only production. What is the main factors? The main factor to have the rootstock, to have the varieties, to know how to prune, to know how to make the design. Smart tree, which is our type of tree. A lot of nursery do it now, but well, our smart tree, mechanization. When I say mechanization, I'm talking about all from day one. All things you do in the orchard can be mechanized. So varieties, for example, European varieties different than the American varieties. European varieties. Now all the selection of new varieties are late blooming, very important to be planted in area where is the risk of frost. Number two, to be self-fertile, and number three, to be productive. Rootstock, for sure, to design a small tree, you need a small rootstock, dwarfing rootstock, I'm sorry. And then how to design the plantation. Well, this is the smart tree, just to give you an idea. Very important when you talk about the super high density and mechanization, that all the tree to be like each other, because the machine doesn't know small tree and big tree. Machine will go. If you have a big tree, the machine will break it, and if you have a small tree, the machine will, go through without any effect. So they said, I have very short time, so this is the smart tree. Smart tree is 55 centimeter. We top it 2 or 3 times. Easy to transport. Easy to make. Designed to be mechanized from day one. I'll jump this. This is how the super high density system goes. Let us suppose that you plant our smart tree in March, April, May. You start to prune. June, July, August, September, October, and this is how it comes. And this small picture show you that from 4th month you can go for mechanization. And this is how it becomes in October. This is the first year. So 2nd year you start to see some production, and 3rd year you can start getting in production directly. This is how you build it. We call it wall. So to be mechanized, you need to build a wall. So it takes like 2 years. And this is a mechanization, topping, hedging, even all the treatments. And this is a beautiful picture. Well, this is orange, but you can see when you make the treatment, there's no treatment go from to the other side of the row, because I mean you just give the tree what exactly the tree wants. So you even save in all the treatments. And this is over the row machine to harvest. This is another picture to show you the different canopies. In super high density system, the canopy is only 5,800 cubic meter. In traditional system, not traditional, in the high density system, it's 15,000, which is a very big difference, having in mind that production more or less the same, and this data from Spain, not from the States. Yeah, I don't have more time, so I'm going to finish here. This picture was taken from Italy last month, the harvesting. And just I want to say something very fast, that we have here in Georgia very beautiful, small but beautiful orchard, a trial area, and I invite you to contact my colleagues, Albert, Gigi, Gaga, or Vajo. Those guys have the key of the farm. Thank you.
დიდი მადლობა.